Okay, good evening, everyone. Yeah, please confirm you can hear me.
Yes, I can hear you.
Okay, okay. Yeah, good evening. Okay, so yeah, so welcome to class. Today we're going to be looking at functions, right? Yeah, we're going to be looking at functions in Kotlin, in programming actually. Yeah, but with respect to the language Kotlin, what it is, and how you can actually create functions and get to play around with them, right? So let's just start, right? Let's start. So in programming, right, function basically is just a group of related statements that a specific what task, right? So basically functions are used to break a large program, right, into smaller chunks, like just smaller, or we call them modules, right? Modular chunks. So what we talked about, what a program is, just a set of instructions, right? So let's say we want to list out a set of instructions on how to bake cake, right? You can actually break down, you can have about 4 or 5 processes, let's say 2, 3, 4, right? More like, what are you trying to do? You probably want to list the steps, and there are a lot. Probably there are just a lot of steps to bake a cake, for example. You could decide to actually say, okay, fine, let me group these steps into similar actions, actions that are kind of similar, right? So when you group those steps, right, let's say you group it into 3, right? All together, what you have just done, the whole of that is just a program towards that shows a user how to bake cake. But those individual groups are what we call functions. Okay, so that's just more like a straightforward definition, right? And an analogy of what a function what is. So we're going to be talking about, we'll start by talking about types, the types of functions, right? Um, because in Kotlin, basically, right, or generally, there are two types of function. There's what we call the Kotlin standard library function, and then we have the user defined function. So um, let me just write that down. Right, so we have the Kotlin standard library function, and then we have the user defined functions. Okay, so now so let's start with the Kotlin standard library functions, right? So basically, there are built-in functions in Kotlin that are readily available for use, right? They are built in. They are just all you just have to do is make use of them. And we have been using a few of them. A typical example is the print, right? So the print here is a library function. And what does the print function do? It prints a message to the output, to the output stream, where a monitor, your terminal, or whatever, right? That's just a function. That's what it actually does, right? There's also another one, which is what the square root is a function also. And what's the function? What does it do? It returns the square root of a number. Are you getting me? So these are standard library functions, Kotlin standard library function. They are inbuilt. They have already been set up. All you just need to do is to call them, or rather use them, right? Okay, so let's try using the square root function, for example. Let's say we have let's create a variable called number, and let's use 5.5, for example, or let's just say 10, right? And then I could decide so let me just say print results equals, so let's just do this. So we use, of course, it's a user, sorry, it's a standard library function. It's inbuilt, right? So can call it by say using the math dot square root, right? And then I'm going to now pass in the number variable that I created, right? So let's actually just run this. Okay, sorry, we'll just have to. This will probably give an error. Yes, so let's close this out. Okay, so this is basically a function that was returned. So if third type is int. Okay, so you can see it's actually expecting a double. So we'll talk about parameters and a lot of that. But what it was expecting here is a double. So but we gave it an integer. So let's make this a double by just saying 10.5. And then I'm going to run that, and yeah, so you can see the result is what 3.2 data. So that's an inbuilt what function, right? So there are a lot of that. There are a lot of them. I'm going to just drop a link right later on for you to just get back and see. There are a lot of standard library functions, but today we're going to focus more on the user-defined functions, right? So of course, user-defined, as the name implies. So these are functions that you define yourself, that you create yourself, right? Because you can actually create functions by yourself. So now the question is, how do you do that? How do you create a function by yourself? So now, the only reason we're able to make use of this square root function is because it has already been defined. So before you can call a function, so whenever I say use a function, we also mean calling the function. Both of them work hand in hand, right? So before you can actually use a function, you actually have to define it. So we can only use the print function, we can use the square root function because it has already been defined. So how do you define a function, right? So in Kotlin, you use the fun keyword fun, right? You use the fun, which is a keyword for what function, right? And then the next thing is to give the function a name, right? So give the function what a name. So I could say my function is called print my name, right? You could call it anything, right? Now the next thing is what is the parentheses, right? What you call brackets, what's called parentheses, right? And if you notice, it is empty, right? This parentheses here is what empty. This means that the function does not accept any arguments. We'll talk about arguments later, right? We'll just keep that. So this means that this function called print my name does not accept what arguments, okay? So, and then the last thing is the curly brace, right? Right, the curly brace. So this is actually the body of the word function, right? So the code inside your curly brace is the body of the function, right? So that's actually how you would create a word function. So how do you call a function? So first thing you need to note is this: you don't create a function inside a function. Now we have this function called what main. Now the main function is basically just the entry point. So whenever your compiler, whenever you want to run your code, it looks for the main function, right? That's the entry point, okay? So, but you don't create a function inside a function. So I'm going to take this out of here and then put it here. So a lot of you actually made this mistake, right? You're not paying attention to your curly brace, right? Some of you, I just had to just manage and just okay, know that, okay, look, this is what they are trying to do, and then I put it back inside and their code was working, right? But you need to pay attention because I will not do that in the subsequent task, right? So pay attention to your scope. Since you're using one compiler, when you click on the opening curly brace, it actually just shows it. There's a way it just highlights it, and then you can see the closing curly brace. So if I click on this in line 15, right, you can see there's more like this, more like it's enclosed, like in a space, and there's a stroke around it, right? That shows you where the function starts and where it ends. So you need to pay attention to make sure that whenever you're creating a function, it's not inside of another function, okay? You're not creating a function inside a function. And then you need to know that whatever you want to actually execute, it has to be in the main function, right? But of course, when you're creating another function, you don't create a function inside a function. But what you do is this: you create it outside of the main function, and then we call the function. So to use this function here, all I have to do is just call it. So I'm just going to say print my name. That's all. Okay, so that's basically that. So think of it this way: you have a house help, right? You have a house help, and her name is let me not use the let me not use the conventional name. So let's say the name of the house help is what, Kotlin, right? So and what is Kotlin's job? Kotlin's job is to clean the house, do whatever it is. There's a lot of code inside that house help called Kotlin. A lot of code instructions, program, right? Function. So when you want to make use of, when you need the services of the house help, what do? You just call the house help. And how do you call that? You call the house help by the house help's what? Name. So that's just the same thing, right? When you want to call your function, you just call what the function was name. That's all, right? And then you pass in this what parenthesis, very important. Yes, like we said, it's empty now, but what it does is that it takes what arguments. I'll talk about arguments, but let's just take it step by step. So that's basically how you call a function, right? So let's say in this function called print my name, I just actually want to print my name, right? So inside this function, I want to say print, or let me just, okay, yeah, print my name. And then I'm going to say my name is admin, right? That's just that, for example. So yeah, this is fine. My name is admin. So let's just comment this out, right? So when we run this, so what am I doing? First of all, let me take this out, right? Let me take this out. Or let me just comment it out. So when we run this, nothing shows because there's nothing for, there's not, when the program is run, there's nothing in the main function. Remember I said that it comes into this main function, and that's the entry point. There's nothing here, just comments, and it doesn't run comments, right? But we have this function that does something, and what does it do? It prints my name is admin. So how do we use this function? We use it by what? Calling it. So when I uncomment that and then run, so we should see my name is admin, right? Boldly written. You can see that my name is what? Admin. Okay, so that's actually how you what? Create a function, and that's how you actually what? Call the function, right? So let me do it this way so you can actually see this. So let me, so you get to see the difference, right? So I'm going to, let's say, print ln. So printing, this is printing from my personal function, right? Okay, and then we have this. And then before this, I want to just say print, this is printing from the main function. Just playing around. Okay, so I'm going to run this. So first of all, you can see that what are we doing here? We are printing this. So this statement is coming from the main function. Now, but after this, remember, these are just the only two things that is run inside here. These are the two codes that are executed, right? So, but when it prints this, right, this is printing from the main function. The next thing we are doing is we are executing this function. And what is inside of this function? It comes inside and sees that, oh, inside this function, one of the things you want me to do is to what? Show that you're printing from your own personal function, and then also print this. My name is admin, right? So at any point, if you have questions, just raise your hand, right? So that's basically how you create a function, right? And that's how you would use a function. So this print my name function, right, does not accept what? Arguments, like we talked about, right? Like I said, it doesn't accept arguments. We'll get into the one that actually what accepts what? Arguments. But basically, what are arguments, right? What are arguments? So let me use this analogy, right? If, for example, you have a driver, right? If you have a driver, someone who drives you, okay, you hired him or her, right? And then the person, the function of the person is to drive you from 8 a.m. to 5 p.m. or let's say 6 p.m., right? And the person resumes in your house, whatever, by that 8 by that 8 a.m. So now when the person comes, right? When the person comes by 8 a.m., does the person need something? Let me pick your brain. What does the person need to carry out his function? Does the person need anything at all to carry out his function as a driver? Let's talk. Let's talk. You can just unmute or raise your hand or maybe use the comment box. Like you have it, you are the driver, right? The function of that young man or young woman, rather, of course, you can have female drivers, is to drive you from 8 a.m., come to the house, pick you up from 8 a.m., drive you to wherever you want to go to let's say 6 p.m., right? And it's done, right? Now, the question I'm asking is, does the driver need anything to perform his or her function? Quickly. Someone said, okay, whoever say he will need the key to the vehicle to drive. Okay, Chinazo, go ahead. What about you?
Assuming the boss has like two different type of car, there should be a specified car you need to carry to perform his function.
Okay, good. Let's say the person, his employer has maybe 2 or 3 more cars, so you need to know which of the cars, right? That's what you're saying. Good. Okay, so Ebola says he needs the key. Then I say he needs to know the particular car he's actually going to, make use of, right? Okay, so let's use those two. So it means that if your driver comes, let's say you have 10 cars, right? Okay, the first thing he needs to know is, sir, what car are we going with? The second thing is get the key of the car, right? Let's use just those two. Now, those two things are what we call arguments, right? Or another word we can use is parameters. So basically, they are extra information, extra data that the function needs properly execute. That's just it. So that's what arguments are, right? They're just extra information, right? Requirements that the function needs to carry out its task. Okay, so take note of that. That's basically, I think that actually just explains that. I think that's a very simple explanation. But if you don't understand, you can just let me know. Okay, so a function can actually take a parameter or an argument. So I'm going to use those words interchangeably. They mean the same thing, right? Okay, they mean the same thing in our context. So our function here, prints my name, doesn't take any parameter. It doesn't need anything to perform. It's just call it. That's all. So when I just call, hey, print my name, it prints whatever. It just prints it because this is what it's contained. Well, this was contained in that, right? So also you need to, the function, right? When your function, we'll talk about function that returns a value, right? So returning a value means if you're performing your task, I am expecting something, right? After you are done. Okay, I'm expecting something after you're done. So we could still, I don't know if that's the best analogy, but we could still say that the fact that the driver will return the key, right? Probably that's one of the things you expect, because you definitely do not want him to go back home with your car key, right? So you can have functions that after execution, they return a value. They return something, right? And then we'll look into that. So, but whenever your function doesn't have any return value, it returns the type, it returns what we call the unit type. Your function can return an integer data type, it can return a string, it can return an object. We'll talk about classes and objects much later. But when it doesn't have a return type, its return type is units. Okay. So let's now look into functions that take a variable. But before then, let's do some modification. Let's say add. Let's change this function to call it add number. Right. So what do I want to do? Let me just take 2 numbers. Right. I'm gonna say. So these are functions. Also, I want to create a function that adds. Let me say add 2 numbers, right? That's the name of my function, right? So you can name it whatever you want. So I'm going to create a variable called let's say num1, and let's say 5, var num2, and let's say that is 10, right? and then I want to create a variable called sum, but yeah, and then that would now be num1 plus num2.
How to be anything? I can't make money now. Talk to me.
Okay, so please be careful not to unmute your mic if you have nothing specific to say, or better still, just raise your hand. Okay, so let's say we want to just print out the so this result, that is the sum, right? So I could just say sum is sum, right? Could just say sum is sum. So when I run this, let me just put this testing. Okay, so I want to now call this function, the function I just created. So I'm just going to call it and then put in my parentheses. So this shows, like I said, it doesn't take any argument. So I'm going to run this, right? And then let's see what we have. So when we call this function, so you can see this testing is for this, and then it shows print sum is what, 15. Because in our function to add two numbers, we're taking this, and then we're storing the sum. When we add the two numbers, we store it here, and then we are printing it out. So that's what this function does. The function what prints out the sum of what, two numbers, right? So, but what if I want to, be able to put in the number when I'm calling the function, right? I want a situation. Okay, Yebola, your hand is raised. Go ahead.
Yeah, thank you. This function had two numbers and the variables we created. I'm just thinking, is it not possible that we can have the sum is 15 without creating a function for it?
Sorry,
Just
come
have
again.
var num1, var num2, then var sum equal to then print sum. Is it not possible that we'll still have the same answer, that sum is 15 without having to create a function for it?
Yeah, it's very possible. Very possible. I think we have done that before. You can actually
Yes,
do
that's
that,
what.
of course. Yeah, of course, definitely. You can do that. But you only achieve that if this whole statement is inside this main function. That's it. So that
Okay.
works. Yes, that works, right? So if you have the whole of this right here, this is what you're saying, right?
Yes.
Yeah, definitely. We've actually been doing all this now, right? So you can actually have that, and then this will give you testing, print it to, so first thing to print is testing, then give you sum is 15, which is still the
Yes.
same thing. Yes,
Yeah.
that
Thank
works.
you. Thank
Yeah,
you.
okay, okay, so that's actually that. So let's move on. So what if we now want, I don't want to, in the function, I don't want to just define the variable, the number there, right? I want to know, I want the user to be able to, freely just put in whatever number he or she likes at any point, just like your calculator, right? So that's where parameters come in, or arguments, right? I said I was going to be using both of them interchangeably, right? So what do I do? This is how it's done. So I'm going to first of all give it a name. The argument or the parameter, I'll give it a name and a type, right? So I could just bring, say, my num1, and what data type should num1 be? I'm going to say int. Give the next one num2. What data type should num2 be? I'm also going to say int. So with that, I'm going to take out these two. Yeah. So what does this? So this is it. So this is a function that takes two parameters or two arguments. So it means that when I call this function, I need to provide two numbers for it to be able to carry out this sum operation. I need to give it two numbers. So let me run this, and then you get to see what I'm talking about, because I have called the function here, right? So you can see that we said error. Yeah, the error here said no value passed for parameter num1, no value passed for parameter num2 in the function that we called. So when we call this function, we didn't give it the requirements that it needs when the function was created, right? So to solve that, I'm now going to, and what does it require? It requires a num1, which is an integer. So it requires two numbers, num1 and num2. So which is two arguments. So I'm just going to give it, since they are integers. So I'll give the first argument, right? I'll give the first argument, let's say 7. And then the next argument, after that, you put a comma, and the next argument of 9. So what does it do? It reads the first number as 7. Here becomes 7. Reads the second number as 9. Here becomes 9, of course, and then it does 7 plus 9. So we should see 16, right? We should see sum is what? 16, right? So this is a function that takes what? Parameters, that takes what? Arguments, okay? It's very, very important, right, that you know this. Now, but you could also have, remember, we talked about return, right? A function can return something when it is done, right? When it is done, it can return something. So in returning, just like we gave, the analogy, right? Okay, the driver, after it's done his function for the day, is expected to return the what? Key. It's expected to return something, which is what's the key, right? So we can create a function in such a way that, look, just when you're done executing, give me the value, give me the result, of executing that word function. I want to use that result for something, right? Just give it to me. Don't worry about it. Just give me that stuff. So how do we do that, right? So I'm just going to be modifying it. So this function now, I'm going to just modify it to actually return something. And how do we do that? So to return, we just give a colon, and then you specify the type of data that should be returned. The type of data that should be what? Returned. So I'm going to say integer, int, because I want to return an int. The type of data I want to return is what? An integer, right? I want to return an what? Integer. So when we do that, you don't need to print again. So this function, we don't need to print anything, right? Because here we are printing the sum. Before we were printing the sum, but now I want to return the sum. I don't want to print it. Just return it to me. I'll print it myself, or I'll do something else with it, right? So first of all, let's run this. We have modified that this function should now return something. So let's run, and then you see this error. You can see a return expression is required, right? A return expression required in a function with what? Block what? Body. So it's expecting something. So you have indicated that it should return this. So how do we solve that? Before I take out this, let me just give it a return. So we use the keyword return. That's why I said a return expression is what's required. So what do we want to return? I want to return the sum. So when you're done adding, right, I want to return the what? Sum. Give it back to me. Give me back the sum. I will do whatever I want with it, right? Okay, so here, I don't want you to print it. I don't want you to print sum is sum for me. Leave it. Just give me the sum. Thank you very much. I don't send you. Don't do busybody. That's basically what this is actually saying, right? So I'm just going to comment this out and then run this. So let's confirm we do not have any errors. Okay, so we don't have any errors. So we can only see this first statement being printed. So probably let me just take it out, right? So we see when nothing is printed to the screen. So yep, so nothing is printed, right? Why? But we are calling this function. This is because when we created this function, we are returning what? A value, an integer value. But what are we doing with the value? Currently, we're not doing anything with it. So when you call this function, it has returned a value to you, an integer value, which is actually 16, but you're not doing anything with that what? Value. You're not doing anything with it, right? So the question is, what can we do with it? What can we do with that, right? So okay, so I could do there are a lot of things, right? So first of all, I could decide that, okay, fair, let's store it here. Store it in this variable and then print the variable. So what are we doing here? So this function is going to return an integer, which is 16. So it stores it in result, and then we are printing the result. So let's run that, and then we should see 16. Yes, so we see 16. right? So that's actually what when you create a function that returns a value, right? And this is very, very important because a lot of times you don't want to make use of a a value, or you don't want to carry out a particular action, right, in a particular place. So this is just, we'll talk about local and look, I think I mentioned local variables and stuff like that, right? So sometimes you don't want to carry out an operation at this point. Let's say at this point, we don't want to actually print the sum. We want to use the sum for something else. So that's the thing, essence. That's why we actually have functions. So when you break a full task, a full program into smaller chunks, right? What do you want to do? So when this function is done, just give me your parts, give me the result of your part. Hey, give me yours. Hey, give me yours. Then I will now use everything to what, kind of do whatever it is I need to do. So let's say, for example, you're doing a cooking, you want to cook, right? And you want to have two persons. So you can say, okay, hey, you're in charge of cutting the leaves, right? Hey, you're in charge of cutting whatever, bringing out the spices and measuring them and stuff like that. You're in charge of boiling whatever, or steaming the meat or something like that, right? When these people are done, what happens? When the person that is steaming the meat is done, what does he do? He just brings, okay, I'm done. He returns it to you. The person who is cutting the leaves, when they are done, they return it to you. Right? Then you take in everything and what, finish up. So that's basically the idea about that. Okay. So I don't know if there are any questions. I think I'll just take them. Well, if there are none, we will move on. So that's how parameters or arguments work, and that's how the whole return value actually what works. Okay. So that's actually that. Now let me just give us I remember saying that if the function doesn't return any value, the return type is what, units, right? The return type is what, units, but you can actually specify that it should return something else, just like we did here. I could also, let me give another example. All right, I could also say, okay, for example, get a function called get name, right? So get name, I want it to get two things: first name, and first name is of type string. Then I want you to get your last name, and last name, of course, is of type string. So interestingly, right, I want you to what, then return a string. So this is just another way. I'm going to write this function in a different way, and the only reason I'm writing it is because this is just the only thing this function does. So return first name, last name, and then I'm going to just put this inside here. So this is just another function. Just gets, so what does it do? It's a function that returns a string, right? So what are we returning? First name and last name. So I can only do this because this is the only operation I'm going to take. Of course, if there are much more other things, I'll just switch to having a curly what, brace, right? I'll just switch to having a curly what, brace. So of course, if I want to call this after printing the result, I'll just say get name, call get name, and then passing the what. So it needs two things. It needs me to give it the first name. So I'm going to say admin. So of course it's a string. So admin, and then the next one, admin. So we should see 16 for this print statement, and then we should see admin, admin. Okay. Well, admin, whatever. Okay. So okay, so sorry, it actually returns, but we're not doing anything with it. So let me print it. Okay, yeah, so I'm printing whatever, since it's returning something, so it's going to return it to this print line function, and that will just print it out for me. So should see 16 admin. Yeah, so that's actually that, right? Okay, so just displaying a name. Okay, so that's actually just kind of like an introduction to functions, right? I know some of you are like, okay, wait, did you just say introduction? Yes, I actually just said introduction. Okay, so but let's take a deeper dive, right? let's take a deeper dive. Now, this is things are going to get a bit more complicated, right? But of course, don't worry, just flow with me, right? So the next thing I want us to talk about is the Kotlin infix, the infix function call, right? Yeah, and a lot you probably use this, not probably, you will actually, of course, depends on you, but you will. So now, but before we talk about this, right? There are two commonly used infix functions, right? There are two commonly used infix functions, and it's the or and what functions, right? Now, let me give an example. Let me give an example, right? I'm just gonna, so of course, since you're gonna have this video, I'm just gonna clear this out, right? So for now, we're done with this. Yeah. Okay, so let me give an example. We have, let's say, val a to be true. So that's a Boolean, right? Good. And then I have val b, which is false, and that's also yeah, that's also a Boolean. And then the result, I'm just declaring a result variable to be of type Boolean also. Okay, right? Of course, we know what I'm doing, so this is not new. So now for the results, I want the results, I'm going to say A or B, right? Now, what does this? This also means A dot or, and then maybe passing what's B. This is the same thing, right? So, but let's see. I hope this runs on this compiler, but it should. So I'm just going, let me just print results. Okay, and then let's see, because I want to explain the infix function call and how you can actually even create it, right, and make use of it. Okay, so yeah, so A or B is what's true, right? Of course, we talked about this, you know, the last when we talked about data types, right? When we talk about or and I gave an example of, you know, if someone sends you an error and they say, okay, get me bread or meat pie, anyone you get is the person is okay because he used the or command or the or statement. But if I say get me bread and Pepsi, right, and you get me only bread, you have not satisfied me, right? Because I'm expecting both of them. So in an and is expecting both, in an or one is fine. Okay, so I'm able to just use the or command here, right? Let me just okay, so I can just decide to do just this, and then I want to, so for, let's say results and, so, and then let's change this to result or. So this, let me say A and B. So I want to now print results and result or, and then I'm going to print result and. Okay, I'm going to print result and. So let's run this quickly. And then, so we should see true for the or, and we should see false for the and. Yeah, so true, and then we have false, because true and false is actually what? False. Okay, so this is what we have. So here we are doing A or B instead of actually doing A dot or. Remember, we talked about this dot operator here. So instead of doing this, we are just doing this, right? Instead of doing this, okay, double quotes. So instead of doing A dot and B, we're just saying A and B. Instead of saying A dot or B, we're just saying A or B, right? So this is actually possible because these two functions, which is the or and the and, they support the infix notation, right? They support the infix word notation. So the question is, how do I create my own function to, you know, to be to carry the whole infix notation thing, right? So you can actually make a function using the infix notation, but there are three conditions. Number one, if the function is a member function, or what we call an extensive function, right? or it has only one single parameter, or it is marked with the, so not really an or, it's actually an and. So it needs to have this. First of all, it should be a member function. It should have a single parameter, and then you should have the infix keyword, right? So let me give an example. Okay, so I'm going to create a class, right? Don't worry, just follow me, right? It's actually a very common example. And don't worry, we'll talk about classes. That'll be next week. We'll get into classes, right? So I'm going to see how to finish this today. So I want to create a function, a member function, right? And I'm going to say infix, which is the keyword. Sorry, but it's small letter. Use the small. Okay, infix fun create pyramid. So it's a very common example. And then in the pyramid, I want to create a pyramid. So it takes rows of type in. So it takes basically the number of rows, right? The pyramid should have. And well, I'm just going to just run this quickly. So create a variable called k, which is 0. Then we'll use a for loop, right? I'm going to say for I in 1 to rows, right? So it depends on the number of rows you actually want, right? So remember, I've talked about functions that take in a value. So whatever the user puts in as the number of rows, 5. So that means this is going to say for I in 1 to 5, right? So what do you want to do? First of all, we want to initialize k to be 0. After doing that, we want to run another loop. And then I'm just going to say for space in 1 to rows -1. Okay. What do I want to do? I want to print an empty space, right? I want to print an empty space. So this is just right. Okay, or I could do 2 or 3, but let's do 1. Okay, so after doing that, after this for loop, then I'm going to use a while loop. Say while k is not equal to 2 times I minus 1. Don't worry, I know you guys will be like, okay, what is this? Don't worry. Print. I just want to use this to explain the infix stuff. So print let's see. I'll just print this asterisk with a space, right? And then increase k by 1, which is that plus k. So increase k by 1, and then print line. I'm just going to call the empty print line. So basically what this is going to do is just going to, it won't print anything per se, but it will take the cursor to the next line. That's what it just does. So print empty stuff, but move the cursor to the next line, right? So so this is just a function here. It's an infix function. So how do we make use of this infix function, right? Okay, so I'm just going to create a variable called p equals what structure. So basically what this is, I'm creating an object. We'll talk about classes and objects, don't worry, right? But I'm just creating an object of this class called p. And with this object, I have access and rights to call this function, right? So which in the actual sense, I would have just done p dot create pyramid and then pass in, let's say, the number of rows I want. Let's say I want 5 rows, right? So let's just run this and see the results. Let's see what we have. Okay, so you can see this is what we have. This is the pyramid we have, right? So but instead of doing p dots, right, I could just say p create pyramid and then pass in the argument of what's 5. Or let me use 7. Right, and that will still run, right? And then you have this, you can see that, right? So that's actually what's the infix function, right? So remember, 3 rules, 3 things. It has to be a member function or an extensive function, of course, which is this. Being in this class makes it a member function. It needs to have only one single parameter, worker parameter or argument, right? Which of course it does. And then the last thing is it must be marked with the infix keyword, which this function is marked already with the infix keyword, right? So that creates the infix what function. Okay, so just to take note of that, right? Just to take note of that. Well, so this is something you can play around with, right? You could decide to add another space here. All right, just play around with it, and it will kind of give you what's it called, different stuff. So it depends on what you actually want. So you can decide to just take this out, and there's just a lot you can play around with, right? Okay, so but that's not why we are here, right? We're not here to actually do stuff like this. Okay, so let's move on, right, to talking about default and named arguments, right? Because we have talked about arguments, right? Or what we call parameters. So but let's look at the default and named arguments. Now, so in Kotlin, right, you can actually provide default values for parameters or arguments when you're defining your function. You can give it default values, right? But so if the function is called with the arguments that is passed, those arguments are now used. They now replace the default ones that you auto created. But if you call it without passing the arguments, right, it will basically just use the default one. Okay, so let's just look at an example, right? Let's create an example. I'm going to create a function. Okay, fun display border. So this is a function, just want to display border, just stuff, right? Or I could just call it display. So display character. Let me just say character. Okay. So I want my function to take a character as the variable, the type of variable, a character of type char, right? And I want to give it a default value, right? So I'm going to assign, because it's a character, so we use single quotes. So I'm going to assign this character to it just by default. And then the second parameter should be a length of type int. And I'm going to give it a default value of what, let's say 10, right? So this is me creating a function. So what have I done? I've created a function that takes 2 arguments, but I am also giving the arguments a value, a default value. So the default character I'm giving here is this equality sign, and the default length I'm giving here is 10. Then I just want to iterate through them, right? So for in my function, I just want to say for I in 1 true length, right? So what do I want to do? So it's run to 1 to 10, right? Let's print no, I don't want to use print lines. I'm going to take things down. So just say print. So print the character, right? So let's call this function, right? So I'm going to call this function in 3 ways, right? I'm going to call it in 3 ways. First of all, I'm going to call so I'm going to do a lot of typing, right? So just bear with me, because I want to show you something. So this is going to be the output when no argument is passed. So when no argument is passed, we'll see this. I'm just going to call the display character function. I'm not passing anything, right? So so for this one, let's say when output let's say, okay, let me just say when first argument is passed, right? So the first argument is the character, right? That's the first argument. So because it's a character, we use a single quote, and then I'm going to use let's use an asterisk, right? And then the next one is when we have, the next one is when we have both, when we pass in both parameters, right? So when both arguments are passed. Okay, so when both arguments are passed, so this, and then let's just use 5. Let's just use 5. So I'm going to just run this, and then let's see the results. Let's see the results quickly. So you can see, so output when no argument is passed. Okay, so let me use a print line here. Okay. Okay, so I need to just for space, right? So you can see, but when no argument is passed, what does it display? It displays just the equality sign straight right after that. So I need to take this to the next line, right? So let me just do, just for now, right? I'm just going to do, because I want it to go to the next line. Right, so I'm just going to do this. I'm going to do this here, right? Okay, let me just add this, right? So it's just to give it move things to the new line, right? So like I said, if you have any questions, just ask me. Okay, so when no argument is passed, it uses the default what's character here. So from 1 to 10, right? So we can see we have 10 of this, right? 4, 6, 8, 10, right? But when I pass in the first argument, which is the for the character, and then I use this, so you can see it prints out this character, but still takes the 10. It runs it 10 times. But when I pass in both of them, it now replaces it. So it prints out. So here I can just decide to use a backslash, right? Just use a backslash, and then we should have 5 of it, right? Yeah. So it replaces the default values. Okay. So that's basically that. But there's also the that's default values, but we could also have named arguments, right? Before that, let's just consider this, right? Let's just consider this before we talk about named arguments, right? Let's consider this what I'm going to do now. Let me just take this out, right? Now, assuming let's see. Assuming I just pass in now the name of this variable, right, is what? Character, right? So what if I actually just say character? What happens, right? I'm going to run this, right? I'm going to just run this. Now this will definitely give us an error, because in as much as it's expecting character, is expecting not the name, it's expecting the value. But let me now change it and give it 5. Now, and okay, let's run this before I say what I want to say. So you can see that it gives us an error. But remember when we tested it, we passed in just one argument and it worked. But why is it not giving me an error when I put 5? Okay, so let's change. And let me give a character. Let's say and then run it. Okay. Because I want to explain the concepts, right? So you can see it's actually running when we pass in one argument. But when I passed in one argument of an integer, which is actually just one argument, right? It actually doesn't run. So what's going on here, right? So the thing is this. We are trying to pass in a second argument, right? The second argument, right? But the thing is this. The reason we have an error, because the compiler thinks that you're trying to provide the 5 you're trying to provide is for the what? Character, because it is expecting the character value first. So it thinks that this 5 you're providing is what? For the what? Character what? Type. And of course, 5 is not a character what? Data type, right? So to solve this, right, that's where the named argument comes into what? Play. Okay, the named argument comes into play. So I can just tell it that, look, okay, hey, length is 5, right? And then what I'm basically saying is I'm explicitly telling you that, look, It's the length I am providing for. I'm not providing for the character. I am providing for the length, right? So that's why you see it runs. It still takes the default character value here, but we have modified that the length should be what? 5. Okay, so that's actually the concept of what named what variable, right? Named variable. Okay, so let's see. I think this is the last thing we're going to look at for functions. It's actually we'll actually look into more stuff, right? As time goes on. But one of the things I want to do is to just make sure we have, the basic stuff that we need to know. So maybe let's say if we can finish that, if we have enough time, we'll look into much more complex functions, right? And then, but of course, at the end of this, I'll give you a task for the week. Yes, I will. I'll probably modify the task I gave to you. I'll probably just modify it, more like an update. Okay, but let's finish up, right? Let's finish up. Now, so let's look at Kotlin recursion, right? Kotlin recursion. Kotlin recursion. Let's look at Kotlin recursion. So Kotlin recursion, which is basically recursive function, right? So a recursive function, right, is basically a function that calls itself. That's a recursive function, right? A function that calls itself, it's actually called a recursive what function, right? And so that's just the definition, right? So a physical example of this, right, is imagine putting two parallel mirrors facing each other, right? Like just two parallel mirrors, they are just facing each other, right? When you put an object in between them, right, of course they'll be reflected recursively. So this one is seen, you're seeing it here, you're seeing it here, right? So that's just like a physical world example. But how does this work in programming, right? How does this work in programming? So let's just use an example, and I'm going to use the most common example that is usually used when talking about recursion. So we're going to create which is the factorial, right? Factorial. So let's create a function that calculates factorial for those of us who did mathematics. Well, all of us did, but for those of us who did and remember, or liked and remembered, so if you did not like it, I'm sure you don't remember it. Okay, that's by the way. So a factorial, right? And then it's going to return a long data type, right? You're going to return a long data type, right? So we're just going to use the return keyword. So return this value if n is equal to 1, just return it, right? I could actually just do something like this. So return if n is equal to 1, n dot to long. So this is just like a conversion. I'm converting the because we're getting an integer here, right? But when you're returning it, I want you to return a long, right? Okay, so just a second. So going to return a long. Now, right, sorry, my screen went off. Let me put that back on. Okay. Please let me know when you can see my screen. Let me know when you can see my screen.
Yes, it's showing.
Okay, good. Thank you very much. So sorry about that. So let's move. So return to long. Else, what do I want to do? Else, I'm going to just calculate the factorial. So here I'm calling back. So this is recursion, right? This is just recursion, n minus 1, right? This is recursion. So what are we doing here? The name of this function here is factorial that takes an integer. So I want to return a long. So what I'm saying, return the return this value if n is equal to 1, convert it to a long and just send it back to me. if the user enters 1, right? Just convert it and give it back to me. The answer is 1, right? But if it is not, what do I want to do? I want it to be n times whatever the factorial. So it's going to run, I'm calling back this function again, right? But whatever the result is going to be, is going to multiply it by n. So what does this basically mean? When we, for example, right, let's run it and then see the result, and then I'm going to just explain that, right? So we're going to just say, let me just create or better still, let me just print, and then I'm going to just call factorial, and then we're going to pass, let's say 4, right? So let me run this, and then I'm going to explain what this does actually. So yeah, so it's 24. So what does this do? The answer is 24, right? So what does this do? So first of all, when we're running it, we're providing 4 here. The very first time we call this function. So we're saying that 4 is passed in as the argument. And we're saying return if 4 is equal to 1. Return, convert it to a long. So maybe you're not seeing this. Remember, I said that you could actually just write it like this, right? Since if there's just one statement, right? So I could decide to do it like this. Maybe I should. Let me just do it this way, right? In a way that you'll be familiar with, right? This is how it would have been. Okay. And then else. Okay. So, pardon me, I know it's not a bit not properly indented, but of course you're used to this now, right? You know, the curly brace. So return if n equals to 1, right? So return if n equals to 1, return it, just convert it to a long, right? And return it. So I could just say if n, I could do it this way. If n equals to 1, return this, else return this, right? Okay, so that's just to kind of help you guys you know, explain that. But I want you to be able to write clean codes, right? You know, so you just get used to it, right? Get used to it. Okay, but we're only doing that because this is the only action we are taking if this condition is actually what's true. If we're going to take some other action, then we'll just use a curly brace, right? A body. Okay, so when we put in 4, so 4 is not equal to 1, so it doesn't convert, it doesn't do this, right? It doesn't do this because 4 is not equal to 1. So it comes down here. So this now becomes 4 times, then it calls this function again because this is a function, which is this guy. So it does this again. So we have 4 times now. Factorial of here is 4. 4 minus 1 is what? 3. So we are passing 3 again. It comes back here and checks this because we are running this function. And in calling back this function, 3 is not equal to 1. So it runs and comes down here. So this becomes 4 times 3 times, it calls the function again, this factorial, which is 3 minus 1 here, which is 2. So n is now 2. So we're passing 2 here. 2 is not equal to 1. So it skips this, comes here, and here is now 2. So we have times 2, and then we still have the times. So 2, we have factorial of 2 minus 1, which is 1, right? So n now is 1. So when we pass that 1 here, it checks here. So return if 1 equals to 1. So 1 equals 1 is true. So it just returns 1.2 long. So it converts it to long. So we just have what times what? 1. Right? So which is 4 times 3 times 2 times 1. 4 times 3 is 12. 12 times 2 is 24. Right? So that's actually what recursion. Okay, that's what so this is just what how recursion actually what works, right? So the first time the function is called, the very first time the function is called, the argument is 4. The second time the argument is 3. The third time the argument is 2. The last time the argument is what? 1. Okay, so that's actually that. But in Kotlin, right, we have what we call tail recursion, right? We have what we call tail recursion. So we just looked at recursive recursion. Now just look at a recursive function, right? But we also have what we call tail recursion. Now, tail recursion is actually a generic stuff, right? Is a concept rather than a feature. So it's not like it's a feature in Kotlin. It's just a generic concept, right? So programming languages, even Kotlin, they use it to just optimize your recursive word calls, right? But not all languages, like Python doesn't actually support it, right? So what's the recursion? Now, first of all, in your normal recursion, right, you perform all the recursive calls first, and then you calculate the result, right? You perform that just like what we did. If you notice, we have not calculated the result yet. We're just performing all the recursive function. That's what gives us 4 times 3 times 2 times 1. So it's when you're done, it now calculates the result from returning the values as as the last one, just like which I showed you here, right? So you don't get the result until all the recursive calls are made. That's why you're just seeing you have only 24, which is the result, right? But in tail recursion, the calculations are performed first, then the recursive calls are executed, right? So the recursive call passes the result of your current step to the next recursive word call, right? So this actually makes the recursive call, it's more like you can call it looping. It's kind of equivalent to looping. So, and of course, it avoids the risk of what we call Stack Overflow, right? So, but there's a condition to using tail recursion actually, right? And that condition is this: if the function, right? So if a function call to itself is the last operation it performs, then you can use tail recursion. So I'm going to give us 2 examples, right? Of a function that is eligible for tail recursion, right? And the one that is not eligible. So first one, right? First one is basically what we just did here, right? So, but let me just let me write it in a different way so you see it. That it's still the same thing, right? But in a way that so I'm just going to write this again. So if n equals 1, so if n equals 1, what do we want to do? Just return n dot to long, right? Else, what do I want you to do? Just return n times the factorial, or calling the function again, of n minus 1, right? So this is not eligible for tail recursion, right? And the reason it's not eligible because the function called to itself, and what's the function called to itself? Is this. This is where the function is calling itself, right? It's not the last operation, right? It's not the last operation. So, well, this is the second example. This is an example now. Let's look at this example. So let me say, let me just say this fact, eligible tail factorial, right? So let's create a this is a non-eligible rather. So of course, your function name can be anything, right? But it should be so this is an eligible tail factorial, right? So let's create the eligible tail one, the one that's eligible. So eligible for tail recursion means that the call to itself is the last operation. But I'm going to use, I'm going to use another, and I think maybe you must have heard about the Fibonacci series, right? You can actually go check that out, right? Now, the Fibonacci series, right? Basically, it takes in, we're gonna give it 3 values, right? So this is just an example. This is an example of a tail recursion. So, eligible tail Fibonacci, I'm just going to call it, or basically I could just say Fibonacci. Or this should be eligible tail recursion, right? And then of course this is factorial, and that so this is what it should be, eligible tail recursion. Yeah, because so we're going to pass in. So this takes 3. So int and then A of type long, and then B of type long, right? And of course, it returns a long. So what do we do in this particular function? We're going to return if n equals 0, right? We're going to return B. Else, what are we going to do? I'm going to call recursive function. I'm going to call the function again, which is eligible tail recursion, and then I'm going to pass in n minus 1, A plus B, and then A, right? So this is just Fibonacci series. You can actually just go so this yeah, you can actually go check that out, right? So this is actually what's a what's it called? This is an eligible tail recursion, because like we said, this in the one that is not eligible, the reason it's not eligible is because it is not the last operation, right? It's not the last operation. Remember, we said that in tail recursion, calculations are performed first, right? Calculations are performed first, then the recursive calls are executed, right? Okay, so but let me use, so that's let's now test that out, right? Where's our main function? So I'm going to call, okay, so this will definitely give an error. So let me use this actual function name. Okay, so after you print that, then let's print eligible tail recursion, okay, which is our Fibonacci, right? Fibonacci. So I'll show you one more thing, right? I'll show you one more thing, but let me just do this, and then let's give it some values. Let's say 100, and then okay, so let me okay, let's just do this, right? But I'll give it, I'm going to use some actual real life scenario here, right? So I'm going to give some real life, I'll just use real life scenario stuff, but let's just run this first. But there's something I also want to show you. Okay, yeah, sorry, we have this wrong call here, Factorial. Okay, so you need to be very careful when you're working with code, especially when you're copying and pasting. So you can see we have this number, right? Okay, but let's do something, right? Let me give a proper example, right? So that when you see it somewhere else, it doesn't actually look strange, right? So and one thing that we do, I'm just going to comment this out. One thing that we do, you can actually tell the compiler, right, that to perform a tail recursion in Kotlin, right? But you have to mark that function with a keyword or a modifier called tail rec, right? Okay, so this is what I mean, tail rec, right? That is what's tail recursion. Then I'm going to call my function Fibonacci. You can actually go read about Fibonacci series, right? It's beyond the scope of this training. So there's a data type called big integer, right? And then B of type big integer. I hope so want to return big integer. So I'm just gonna, okay, so let's just write it. So return if n equals 0, A, so return A if n is equals to 0, else call the Fibonacci series again. So if, for example, the user puts in 0, just return A, return the value of A. But if it doesn't, right, first of all, when you call it, subtract 1 from it, then bring passing B, and then passing A plus B. Okay, so to use this, right, I'm going to comment this one out. So let me just create a variable for n. So let's say n equals 100. And let's create a variable first equals the big integer data, and then we'll pass in 0. So this is just a second big integer, and then 0. Let's use 1, right? Okay, and then I'm just going to print ln. So what's the name of that function? Fibonacci, right? Which Fibonacci, yes, and I'm going to pass in n. So n here that I'm passing is this 100, and then I'm going to pass in first, and then I'm going to pass in second. Okay. So let's just run. Let's run this. Let's run this. Let's run this. Let's run this. Okay. So I don't think this guy has this big integer stuff here. So well. Okay, I did not import it. Yes, so let me import. That should be java.math. Yeah, if I'm not mistaken, it's part of the math, right? Big integer. Okay, so we should be able to use it now. So basically just importing it. That's why it says unresolved reference. It doesn't know that. Okay, so okay. Do I think probably, so what is it showing me here? Okay, unresolved reference, big inter. Oh, okay. I think I made an error here. So it's not big integer. All right, so yeah, you need to be able to read errors, right? It's very important. Okay, so yeah. So this is what we actually have. So this is tail recursion, right? This is an example of tail recursion. So what's basically happening here, right? Like I said, you can go read up on Fibonacci series, right? It's beyond what we are talking about here. But what is happening here is this, right? This program, the Fibonacci series, it computes the 100th term of the Fibonacci series, right? The 100th term. So you can go read about it. So since the output can be a very large integer, that's why we made use of the big integer class. It's actually a class from Java standard library, right? So and then we are marking it with the tail rec, right, to actually tell the compiler that this function is eligible for tail recursive call. So the basically just the compiler will just optimize the recursion. That's basically right. So let's say we do for 10, right? So like I said, you can just go read up the Fibonacci series. It's not really what I'm going to be explaining here. So that for 10 gives you 55. So that's the 55th term. Sorry, the 10th term of the Fibonacci series, right? Is what 55. That's basically that. Now, but the thing is, we can actually use we can actually convert our factorial function to use tail recursion, right? We can actually use make our factorial function to use tail recursion, right? So what we want to basically want to compute the factorial of a number, right? But our first example, which is this one, it cannot be optimized for tail recursion, right? But this is another way that we can actually do it, right? Same thing, tail rec, right? Font factorial. And okay, so I'm going to give it so n of type int, but I'm going to pass in another another variable here, right? I'm just going to call it run of type int, and I'm going to initialize it to 1, right? Then of course I want it to return a long. I've talked about that. So and then let me just copy this if you don't mind. It's basically the same thing, but I'm going to modify it, right? So once we return, so if n is equals to 1, so what we're going to return is not n, we'll just return run dot to long. And then else, what we're going to do is factorial of n minus 1, and then run times n. So this is more like optimizing it to actually use tail recursion, right? Yeah, that's basically that. So of course, when we run this, what give us 24 here, where we passed 4, right? So I could just call factorial. Okay, could call factorial and then pass in 4, right? So you'll notice I don't need to pass in this run here, the value for this, because I've given the default value, right? I don't need to. So I'm just going to call that. So I should still have 24 to show that the factorial still works. Okay, I'm not printing it, right? Sorry, I'm just, it returns a value, so I need to print. I need to print the results or do something else with it. So, but I just want to print it. I don't want to do anything else than printing, anything other than printing, right? So you can see it still gives us what, 24, right? So with this, the compiler can now optimize the recursion, right, in our program, right? Because it is eligible for tail what, recursion. And we use the tail rec modifier, right? That tells it to optimize this whole function, right? So that's actually that for recursion and Kotlin tail recursion, right? Like I said, in your normal recursion, the recursive calls are done first and then calculates the results, right? But in tail recursion, the calculation is performed first, then the recursive calls are what's executed, right? So that's actually that, right? So any question before we call it timeouts?
Can I see the example of the factorial, using factorial as a recursion, as a tail recursion? Yeah.
Yes, this is it. That's in case you want. Probably you're trying it out, but yeah, that's basically.
Just
That's
want
that.
to note it down.
Oh, okay. Well, that's fine. That's fine. So yeah, the whole tail recursion stuff, right? That's something you can read out. So of course, this is a beginner track, so there's not there are a lot of things, there are a lot of advanced concepts in Kotlin that we're not going to be able to get into. But of course, I'm going to give you guys the basic things you need to know, especially when it comes to building mobile applications from a beginner standpoint. But it's definitely going to make you ready, right? So that's basically that. So any other thing? So in your spare time, you can just go check out tail recursion. You can look at recursion, play with some practice, right? Practice, very, very important that you practice, right? And that's how you actually get better, when you actually practice. So yeah, I think that's that. And I think we're going to round up this class at this point. So thank you. I'm going to be dropping. So I'll let you guys know, right? I'll let you guys know. I'll probably just what's it called? Update your task, right? So it means that for some of you who have submitted already, all you just need to do is just go back to your link. Like so for those of you that I don't know, you're still confused, you can just copy this, right? This is just your link, right? Okay, so all you just need to do is go back to your link, right? That's just all you need to do. Or if you're signed in, you can actually save your codes. If you're signed in, right? I remember telling you guys to play around with one compiler. You can sign in and actually play around with your codes and even store them, right? And then you just send me one link and then I get to see everything. But of course, if you want to use just this one link, you can actually update it. When you update it, I'll actually see the updated version, right? I'll see it. I'll see the updated version. So it's not like, for example, for you guys that have submitted, right? You don't need to submit a new link. So if I update the task, you don't need to submit a new link. All you just have to do is go to that same link and make the necessary updates. When you update it, I will see it. Okay. So that's that. So thank you very much. Okay, Oyebola, go ahead.
Thank you. I have an issue about updating link. I
Okay.
think I observed about 2, 3 times that when I work on my link and I save, I keep it somewhere. So I click on the link, I discover that my last saved work does not reflect. And number two, the number oftentimes change. I don't know.
When you say the number, what number
Yeah,
exactly?
this 3ZJM that is in the browser, it
It
changes.
it shouldn't change because that okay, let me give you an example. Okay, so let me see. So this is just me naming this guy, right? Okay. So
Yes.
this is just this. Now this is still your link, right? Okay. So I'm not actually logged in, right? So let's see if probably that is your issue, the fact that you are not logged in, right? So even if I refresh, I still get to see what I have done. If I
I
open
think,
it in
sir, I think what you need to do, you need to save it. I think you need to save the,
no,
just
this
go to,
uh,
how I used to do my own. I will just write my task. I will just click on these 3 dots and save,
this
something
three
like
dots
that.
here.
Yes.
But
It
there's
will,
no, it actually doesn't have a
Where
save.
wait,
do you
The save
save?
is
There
down
is
here.
no
No, the save
save
is
there now.
automatic. It's actually
It save
automatic.
automatically.
So except you're logged
mine.
in. So I've not tried to
Okay, try to click that new. Try clicking that new.
no, the new would create a new what's it called?
How I do my own. How I do my own. When I click that new, when I click that new, it will give you an hello world kind of
Yes,
stuff.
it will give you a
So
new
once I clean that hello world, that place where you write my task, we bring out something that looks like pencil. I will not click on that, change the name, change some description, and I will click on save. It will save. That's
okay.
how I
So
do my own.
let's so what's his name? Let's run that. Let's try what's here. So you say what the first thing you click on new.
Yes.
Okay, so this gives
You
you a
then
new
clean that hello world.
this one.
No, the one in the code. That print hello world, print hello world. See, no, on your body, yeah. Clean it.
Ash- Okay.
Just clean that print hello world.
Uh-huh.
Clean it, like remove that line.
Okay, to
Clean that
remove the
line.
line, you should say
Yeah,
remove
clean
the
the
line.
line.
Okay,
It will click that pencil, this thing.
okay. And then
Then
change the
you
name.
now type in the new name and click on save. So
That's what
whatever
it
you
did
do,
also.
That's what I
that's what.
did before now.
That's what
That's
it
what
did.
Okay,
yeah.
yeah,
So that
that's what I used to do. So whatever you do now, it will now be saving automatically. I think that's how it
But it will not still the
works.
code is still the same. It's not about what you save. I think my concern is with the code. The number changes.
when you
I
say
had
the
to share
number,
the links.
what number exactly are you talking about?
The 3ZJMA, I believe
No,
that's
no.
the
It will change if you change this guy, right? So if you notice the one I did is still this code. It has not changed from this, right? This is a different one now. It should not change. If you change, that means you have tampered with this. Let me show you something. This is what we did, right? This is what we did. I changed my task
3ZJMA.
and here. So you can see this is the code. MYZN.
Yes,
Good.
yes.
If I refresh, when I refresh or whatever, it still stays the same. It's a
Yes, I
generator.
understand. But sorry, the second one you copied it to. Just let me see.
This is
You see,
this is
it's different now.
this is a new stuff now. When this guy said we should, I did a new.
Oh,
So
okay, okay.
let me show you now. These three EZCJ. This is MYZN. So if I create new, right, it gives me a new
It comes with
hello
another
world.
one. Yes,
So when I clear this out, just like this guy said, you see it changes this, right?
yes.
Good. So let's say testing, and I save, right? You now see a new URL here, a new code for you here, of course. So you can see it's a different one. So it's because you created once you create this new, that's a different what think of it as a different sheet. or a different a new page.
Okay.
Right? Yeah. So, but nothing changes. You see this one? Okay, we can do a test. Let's do a test.
So
How many
look
of you
at another thing I normally do. Another solution. What I normally do that work for me, it can also work for anybody.
Okay.
When I finish one particular question, I click on that three dots. I download it. You
Okay.
understand?
Yeah.
So then I will now create a new one. Write another code. I'll click on the three dots and download it. So after writing all the whole code, after solving all the whole assignment, I will now open a fresh one that I will use as a link to submit my assignment.
Yes, you now paste
Yes, I will now be opening everything one by one. I'll just paste it.
Paste
You
it,
understand?
yes.
After that, I will now copy that particular one that has the three questions that I paste and submit the link.
So,
that's how I do my own. So it can also work for anybody. Because if you write the whole code together, it's going to show you an error. So that's what I do.
Okay. So but the thing is, whenever you are, it's not about even if you write the whole code together, it's not meant to throw you an error if you section everything. Remember that the compiler runs everything in the main function. So if you're don't just paste, right? Try to make sure that it works. I can show you a lot of a lot of tasks, right? Let me probably maybe just even give you guys should I? I don't want to show someone's task, but I kind of would want to give you guys an example of what I mean, right? So there are a lot of persons that made very, very. So let me share this whole screen so you guys see it, right? Okay, so you can see. That's why I want you guys to be careful. So you can see this. Let me know if you can see this other task I just put up.
Yes, I can see it.
Okay, good. So you see now this person just probably did the same thing. I don't know who this is, and pasted, right? Right. So it's fine that you've gone to do it somewhere else, but see where you pasted it. It is not even inside this main function. So that's why if I run this, it will not work. Because all these things are outside.
It will not work.
So what you should
outside
do,
the main function.
What you should do is to paste it inside of the main function. And the interesting thing is I can even edit the person's code. That's the thing about these guys. So sorry, I want to just cut this and then paste here. So let me just run it, right? So so you still have
Anything again, you now be indentation.
Yes.
Why I normally do my own. And the one I'm going to use to submit my assignment, I will remove every code inside it.
So
Or the whole word. I will just be pasting it. That's how I do my own. Paste the one that I use.
Hold on. So see here, a lot of you guys, right? I just gave people a let, and that's why I'm doing this on this live call, right? So someone checks. You need to be very careful. First of all, this is a problem in this code, right? You don't create a variable and give space. A variable name does not have space.
Space, yes.
So you can see that's the first thing this guy is pointing out here, right? So let's just clear that and try to solve that. Second thing, you can see this else. Why is it having a colon? Shouldn't have a colon here. Right? Shouldn't have
curly brace.
Should have a curly brace, or you put everything. If you want to do it, you doesn't want to use curly brace, then you can have this. You can have this. Since it's just one action you're taking, if that condition is true, you can have something like this instead. If you don't want to use a curly brace, right? So indentation is a problem. But apart from the else, so
I think there is something you click now that made it to indent automatically. What's the shortcode?
So what you do, you just highlight and press your tab key on your laptop, tab.
I will highlight everything. Should I the way you just highlighted?
Whichever one you want to indent. So it's not like if it's everything fine. If it's everything fine, if it's just one line, you highlight that line and press your tab key on your laptop. So what other error do we have here? This is the odd number. So this operator, okay, doesn't work on. So this is just, so you can't say, so look at this now. This person is calling this function wrongly, right? This person is calling this function wrong, this variable, right? Very, very wrongly. So it should just be odd number, right? That's just, so you can see I'm seeing the errors, I'm fixing it based on what the person did wrong. So you can see in line 16, which is the next one, right, line 16,
Weekday.
weekday. So valday. So you cannot say weekday. There's no variable called weekday. That's why you see unresolved reference. The variable here is day. So it's not supposed to be weekday because you have stored it. This is what we should have, day. Okay. So let's run this and then we'll check out more errors, right? Let's see, and then just fix them. Okay, so we still have this if odd number modulo 2 print line. Okay, so there's what else? Okay, so it's just that print line, and then this unresolved reference for weekday again. Okay, so here is supposed to be day because it created a variable of day. So these are things you need to pay attention to, right? For whoever that did this. And then okay, so we still have one error, which is what inline operator, the number is even else print. So odd number modulo 2
equals to.
So if this modulo 2, okay, so that's the thing. The odd number here is this is a string, not an integer.
You make it a string.
So you get to see these things, right? And interestingly, you see persons now shouting, I've not been graded, I've not been promoted, I've not been protected, I scored 30. Why? So let's see, type mismatch, right? Modulo 2, the number is even. So we actually need
what about maybe to generate the results if
so hold on. See, you can see infert type is int, but Boolean was what expected. So if this is equal to 0,
exactly.
Yeah. So that should solve at least this problem. So let's see. Do we still have? So you can see the output provided. The output provided is odd. Yes, 20 is greater than this. Okay, we didn't use print line. That's why I had.
Yeah,
and then we have Monday. So yeah, that's basically that. So the thing is, what I have done, this person should be able to see it because because I have access. That's the way the one compiler is. The person is able to see it, right? So another thing is when you log in, you're able to save your codes actually when you log in. And that's one thing I would want you guys to do. So let me show you an example of somebody that did that, right? And that's Dilo, right? So you can see, so what he does is that he just submits his codes to me, and then I'll just see the recent task based on the name. So, but this one, you have to create an account first, right? He has an account, right? This is an account. So he has 8 codes so far. So this is something I want all of you to actually what to do. He joined 9 days ago. He has returned. So this is also a place. Yeah, interesting. Yeah, so create an account. You can save your codes, right? So these are his codes, right? And then so he just sends this to me, and then I'll just check it, copy it, go to one compiler, paste it, and then check that it works. So, but this is also another way for you to have your tasks and codes saved, something you can always go back to, right? So, but that you have to sign in, you have to create an account with either Google or whatever. So that's basically that. Okay, any question? Any other question? Oh, we're good. We're good.
Just to confirm.
Yes.
So our last task will not be graded.
Well, that's a tricky question. Okay, so this is what's going to happen, right? This is what's going to happen. It will be graded. Right?
Okay.
Graded, but I will not grade now. So I'm going to extend the submission date to Sunday.
Okay.
And then I'll edit the task.
Okay.
Yes, that's just what I'm going to do.
Well, actually, I'm asking because I submitted. I just want to know how I performed.
Don't worry, that's fine. So, yeah. Okay. So
I had a challenge doing it, so
don't worry, you'll be fine.
I did my best, yeah.
I know you can do better. So I'm going to update the task, right? I'll just update it. So all you have to do is just the same link you submitted, just go there and make your edits. You don't have to
Okay.
submit again. So be careful not to lose that link. Just go there, make your edits. I'll see it. Okay, so let's do.
I'll copy it out.
Okay, good. Okay, that's fine. Okay, so I think that's going to be that. I'll edit that task today. I'll drop an announcement on the channel. So please, you can encourage every other person. They should come. They should watch this video, especially to the last where I did this clarity, because some of you, I just had to kind of arrange your stuff for you just to be sure that it works, because I noticed you probably did what this other guy did. You know, they downloaded and then pasted. Yeah, so individually it was working, and then you just packed it and submitted. No, it should also work when you put in everything, right? Okay, so
Okay.
yeah, so that's right. So thank you guys for staying to the end, and
Thank you.
see you on the workspace. Have a wonderful weekend.
And you too. Thank you. Good night.
Good night.